Here is a completely reasonable thing to wonder. If you dug a hole straight through the center of the Earth, pole to pole, perfectly straight, and then jumped in, what would happen? More specifically, how long would it take to reach the other side? I've thought about this a lot. Probably too much. And the answer is one of my favorite things in all of physics, because it's simultaneously obvious, completely wrong, and then, when you actually do the math, surprisingly beautiful. So let's dig. Before we throw anyone into anything, we need to know what's inside. The Earth is not hollow. I know some people think it is. Those people are wrong. Here's what's actually in there. The outermost layer is the crust, the part we live on. It's between 5 and 70 kilometers thick. Average density, about 2,700 kilograms per cubic meter. Mostly rock. Feels solid. Is solid. Good start. Below the crust is the mantle. This goes down 2,900 kilometers. It's made of silicate rock so hot and under so much pressure it behaves almost like a very slow liquid. Temperature ranges from 500 degrees at the top to 4,000 degrees at the bottom. Then we hit the outer core. Liquid iron and nickel spinning around the inner core and generating Earth's magnetic field. 2,200 kilometers thick. Temperatures between 4,000 and 5,000 degrees Celsius. And at the very center, the inner core. A solid ball of iron and nickel about 1,220 kilometers in radius. Temperature, approximately 5,400 degrees Celsius. That is the temperature of the surface of the Sun. The pressure at Earth's center is 360 gigapascals, 3.6 million times normal atmospheric pressure. For our thought experiment, we are going to completely ignore all of this. We're digging a vacuum tube through a perfectly spherical, uniform density Earth, and we're going to treat the whole thing like a physics problem, which it is. You're welcome. Here's where it gets interesting. On the surface, gravity pulls you down at 9.8 meters per second squared. But what happens to gravity as you fall deeper into the Earth? Your instinct might be, more Earth above you means more mass pulling you back up, so gravity gets weaker. And you'd be right that it gets weaker, but the reason is more specific. There's a principle called the shell theorem, proven by Isaac Newton. It states that if you're inside a uniform spherical shell of mass, the gravitational forces from every part of that shell cancel out perfectly. The shell exerts zero net force on you. This means, at any depth inside the Earth, only the mass below you, in a sphere of radius r from the center, contributes to the gravitational pull. Everything above you cancels out. For a uniform density Earth, the mass below you scales as the volume of a sphere. M of r equals m total times the quantity r over r, all cubed. Plug that into the gravity equation, simplify, and you get g of r equals g0 times r over r. Gravity decreases linearly as you approach the center. At the center, r equals 0, so g equals 0. At the very center of the Earth, you are weightless. Every kilogram of Earth pulls you equally in all directions, and they all cancel out. Let's look at our equation of motion. As you fall through the Earth, the force pulling you toward the center at any position r is F equals negative m times g0 times r over r. That negative sign means the force always points toward the center, a restoring force proportional to displacement. If you've taken any physics, you know exactly what this is. This is simple harmonic motion, the same math that describes a mass on a spring, a pendulum, the vibration of a guitar string. You, falling through the Earth, are mathematically identical to a pendulum. The angular frequency of this oscillation is omega equals the square root of g over r. Plug in. Omega equals the square root of 9.8 divided by 6,371,000 meters. That's 0.00124 radians per second. The period, one complete oscillation, is t equals 2 pi divided by omega. T equals 2 pi divided by 0.00124. T equals 5,063 seconds. That's 84.4 minutes for a full round trip. One way, surface to surface. 2,532 seconds. 42 minutes and 12 seconds. 42 minutes. The same amount of time it takes to watch a sitcom. And here's the most beautiful part. This result doesn't just apply to a pole-to-pole tunnel. Any straight-line tunnel through the Earth, even connecting two cities at an angle, not going through the center, takes the same 42 minutes. The longer path and weaker gravity component cancel out exactly. Every chord tunnel on Earth has the same travel time. The universe just decided this was elegant, and we're going to have to live with that. In simple harmonic motion, maximum speed occurs at the equilibrium point, the center of the Earth. Maximum velocity, Vmax equals omega times r. That's 0.00124 times 6,371,000 meters. Vmax equals 7,905 meters per second. That's 7.9 kilometers per second. About 28,500 kilometers per hour. Mach 23. You fall in at zero velocity. Accelerate all the way to the center. At the center, you're doing nearly 8 kilometers per second. Then you decelerate, arriving at the surface on the other side with zero velocity. You stop perfectly at the opening, like a pendulum at the top of its swing. If nobody catches you, you fall back in. London to New Zealand to London, every 42 minutes, forever. You are now a human pendulum. Congratulations. Right. Let's talk about reality for a moment. Problem 1. The temperature. You would hit the outer core at roughly 4,000 degrees Celsius. Iron melts at 1,538 degrees. You would vaporize in the upper mantle. Problem 2. The pressure. At just 100 kilometers depth, the pressure is already 3 gigapascals, 30,000 times atmospheric. Every cell in your body would be crushed. Problem 3. The outer core is liquid iron. Your tunnel would immediately flood. Problem 4. Earth's rotation. You'd experience the Coriolis effect and slam into the tunnel walls unless the geometry is exactly right. Problem 5. The deepest hole ever drilled by humans, the Kola Super Deep Borehole in Russia, reached 12.2 kilometers after 24 years. Earth's radius is 6,371 kilometers. We've drilled 0.19% of the way. Completely doable. Give us a few million years. So let's recap. Gravity inside the Earth decreases linearly with depth. Only the mass below you pulls on you. This creates simple harmonic motion. Travel time one way, 42 minutes and 12 seconds. For any tunnel, not just pole to pole. Maximum speed at the center, 7.9 kilometers per second, Mach 23. If you miss the exit, you're a human pendulum for eternity. In practice, you'd be vaporized before any of the interesting physics happened. But the math is beautiful. 42 minutes. Through the center of the Earth. Same as a sitcom. You're welcome.